Okay, so 2021 Specialist Maths Exam 2, VCAA exam. Here we are, question 2. So this one's a complex number question. So when we read, we've got this polynomial and some coefficients and a constant that we don't know. But what we do know is that they are real numbers. And so we can write it in this form here. We're told that Z1, so for this first factor here, that's a real number, and that Z2 and Z3 are complex. So it says state the relationship between this Z2 here and this Z3 here. All right, so if we have a real coefficients of this, then this is conjugate root theorem. So what can we say about Z2 and Z3 is that they are conjugates. So Z2 and Z3 are conjugates. All right, so in other words, i.e. Z2 is the conjugate of Z3, or vice versa, or Z3 is the conjugate of Z2. All right, and so now we have to find these particular things here, alpha, beta, and gamma. And so the way I'm going to go about doing that is I'm going to say, all right, let's let Z2 equal A plus BI. And because Z3 is the conjugate of that, Z3 would be A minus BI. All right, excuse me. So Z2 plus Z3 then would be 2A, and Z2 minus Z3 would be 2BI. All right, now the magnitude of Z2 plus Z3 then would simply be 2A, and that has got to equal 0, and that's from here. So that's why I've gone the Z2 plus Z3 and the Z2 minus Z3, because that's what it was up here. All right, and so that's equal to 0, so from that we know that A is 0. And over here, the magnitude of Z2 minus Z3 then is going to be the 2B part, and that of course is 6, and so B is equal to 3. So therefore what we have is that Z2, which is A plus BI, is 3I, and Z3 would be negative 3I, because they're the conjugates. All right. So the other thing that we know is that Z1 is an element of the real numbers. So what that means then is Z1 would be x plus 0I, which is x, where x is an element of real numbers. So why have I done that? Because what I've done that now is now I'm going to write that polynomial, PZ, and I'm going to say that that polynomial is z minus x, z minus 3i, z plus 3i. All right, and what we also know, given that I haven't used up here, is this, that P of 2 is negative 13, so that's why I've come with this polynomial. So P of 2 is negative 13, and so P of 2 is when you put 2 in for Z, so 2 minus X, 2 minus 3i, 2 plus 3i. All right, and so now we need to, negative 13 equals, negative 13 equals. Now we need to expand and collect our like terms on that, and you can do that on your calculator, or you can do it by hand, but do it on your calculator, and then you would get negative 13 plus 26. All right, negative 13x, I should say. Let me go back here. Negative 13x plus 26. All right, and then when you rearrange that, what you would then find is that x is equal to 3. So what do we have? What we have then is that our polynomial P of Z is Z minus 3, Z minus 3i, Z plus 3i. And then when you expand that, and we need to expand it because we're asked about these alpha, beta, and gamma, which of course are the expanded polynomial. All right, so again, get your calculator out and expand. Okay, you need to be efficient with your time. 3z squared plus 9z minus 27. All right, so that means then alpha, beta, gamma, that alpha is negative 3, beta is 9, and gamma is negative 27. All right, so a bit to be involved with there. All right, next part of this question. Consider the point Z4 is root 3 plus I. Sketch the ray given by arg Z minus Z4 is 5 pi on 6, I should say, not pi on 6. Okay, so where does this thing start? All right, so it starts, it's a ray, as we've told. It starts then at this Z4, wherever this Z4 is. All right, now root 3 is approximately 1.73. So we're coming out here 1.73 and we're up here 1 in the I direction. Now, the other thing that's handy here is to look at what the magnitude of Z4 is. And so the magnitude of Z4 is root 3 squared plus 1 squared. And so when you figure that out, that's the square root of 3 plus 1, which is the square root of 4, which is 2. So what does that mean? That means that Z4 is on the radius, circle of radius 2, this one here. So it's actually right there at that point. So this 1, when you come across with this 1 here, it's right here at this point. Now, because it's a ray, and there's no definitive at this starting point, we need to put a circle there. And we now need to know where it goes. Well, we know it's 5 pi on 6, which is around over here somewhere. But now, where does it actually intersect this axis? All right, well, the answer to that is there's a couple of different ways that we could look at it. And one of them is that tan 5 pi on 6 is negative tan pi on 6, which is negative 1 on root 3. All right. So it's a negative gradient, so it's going to go that way. And rise over run, so we're going up 1 to along with this 2, and then we're going across here root 3. But remember, that out to there is root 3 from here. So if we're going up 1 and back this way, it actually goes through 2. So and then you would have a ruler. So there is our ray. All right. And so that's it. And so this angle around in here is 5 pi on 6. All right. So there's that particular one. Sketching that ray. All right. Now it says that ray that we've just drawn intersects the circle where z equals, the magnitude of z minus 3i is equal to 1. All right. It's dividing it into a major and minor segment. We'll get to that bit in a minute. So let's have a look at this circle. Well, this circle, negative 3i, so it has its centre. I'm going to change my colour here so that when I draw the circle. All right, so the centre is here at 3i. And its radius is 1. So what we've got is we've got this circle going around like so. And my circle is very wonky there, but anyway, we'll cope with that in a minute. So we need to think about what that is. All right, so what it says here, it divides the ray, intersects the circle, dividing it into major and minor segments. Okay, so as you can see, it goes through, the ray goes through, so we've got a big part here and a small part here, so there's our major and our minor segments that we're talking about. All right, so first part A, which is what I've done, sketch that on the Argand diagram. There it is in the orange. All right, I should have probably, marked in that a bit better. So marked in those points there and there, and but anyway. All right, so it says then, find the area of the minor segment. All right, now this is not something that's on the formula sheet. So what you need to be doing is in your band reference, make sure you've got areas of sectors and segments in your band reference. Also the arc length of a circle one, put them in just in case you're going to need them. And so the area of our segment is given by a half r squared theta minus sine theta, where theta's in radian. Now, what does all this mean? All right, so what I've got to do here, I'm going to change my colour again. Oops, wrong one. Change my colour again. Let's go something we're going to be able to see. Let's go the green. All right, so with this formula that I've used, what we're looking at is that triangle, that segment. All right, and what we want is this area in the end here. So what this formula is, basically it says it's the area of the sector minus the area of this triangle. All right, so what then do we need to do? Is, all right, 5.6 there. So what is this angle here? So this angle here, it's all the way around to, from there all the way around to there is 5.6. Take, so 5.6, take pi on 2, and when you figure that, that's pi on 3. So this angle here is pi on 3. All right, now that's very interesting, because if that's pi on 3, now that's a radius of the circle, so is that a radius of the circle. And so this triangle then is an equilateral triangle, this one here. All right, so that length there is 1, that length there is 1. We've got ourselves an equilateral triangle. All right, so if that's an equilateral triangle and this is pi on 3 here, then this angle up here, the one that we're going to use, is also pi on 3, because we've got an equilateral triangle. All right, so what do we know? We know everything that we need to know now for our, to put in our formula. Let me change colours back to blue, so that green doesn't really hold out. So our area then is a half times the radius, which is 1 squared, times theta, which is in radians pi on 3, minus sine pi on 3, which again is in radians. So what do we end up with when we multiply all of this stuff together and expand the bracket? We've got pi on 6 there from these three, then times that, so that's minus root 3 on 4. And you could, if you wanted to, put those together over a common denominator of 12, and if you did put that over a common denominator of 12, you'd have 2 pi minus 3 root 3 as our area. All right, so there's a bit of geometry going on in that question, in that part of the question. Important that you take care when you're drawing your diagrams. Certainly a ruler. If you've got a compass, that's even doubly good, because then you can put your circle in nicely.